Hi there. So in this video, we want to talk about solving equations that either contain fractions or decimals. And most of this is going to rely or deal with fractions. I'll show you there's a technique similar to how we deal with fractions for decimals, but because of calculators, we can usually just use our calculators to handle that part. But the main thing is trying to solve equations that have fractions in them. So here's an example right here. Now, one thing you can do is just solve it normally, all right? And it's just that it kind of depends on you being really good with fraction operations. So let me just show you the basic way to do this, just following along what we've done before. I don't necessarily advise doing it this way, but you can do them these ways, okay? And so the idea here is that I have a variable term over on the left, and then everything else is just numbers. And so I want to move this 3 over to the right side using the opposite operation. So I would add 3 to both sides. Okay? And so whenever I do that, I have x over 6 is equal to, the problem is that I have this 3/4 plus 3. Now, one thing about advice too, some of you might see that that's 3 and 3/4. But you don't really want to deal with mixed fractions doing algebra because it can lead to some miscalculations. Okay, so you really want to get that thing in improper form first. Now, if you do see something pretty straightforward like this, that this is 3 and 3/4 right here, and so we have 3 and 3/4. You could write 3 and 3/4, but remember to work with mixed fractions, you usually need to convert them to an improper. So the next thing you would do is convert that to improper. Or what you could do is just add these two together with a common denominator. You just come over to the side, realize that you write that 3 as 3 over 1. Our common denominator is going to be 4 here, all right? And the first one's already over 4. There's nothing to do with it here. And realize that I would need to multiply the top and the bottom by 4 there. So that's 12/4. Now that you have the common denominator, you'll end up, you remember we add our numerators and keep the denominator, so we have 15/4. So what all that's telling us is that our left side of the equation is x over 6, and our right side is 15/4. Now this brings up a good point now. I remember what we're trying to do. We're trying to isolate x here, but this right here is keeping it from being isolated, but what is this here? It's x divided by 6. So to isolate, I do the opposite operation, so I'm going to multiply by 6 on both sides, all right? And on the left side, that just causes those to cancel, and so I just get x. Now, since I have a fraction times a whole number, I need to write that 6 as 6 over 1. Remember how we multiply fractions. We multiply straight across. The denominator is easy to see that we're going to get 4. And then in my numerator, I do 16 times 5. You might need to do that on your calculator, but you get 90 over 4. All right? And then lastly, notice that reduces. And so 90 over 4, that reduces by 2. So I get 45 over 2. Okay? Now, that's the improper form. If it's not clear if you should use the answer as the improper or mixed, I always just give them both to cover my cases. So that's going to be 22.5. All right? Now, one thing you might notice, if you did that on a calculator, it's going to give you 22.5. All right? But you don't want to answer this problem that way. Okay? Why would I say that? Because our problem came in fractional form. Remember, we always want to answer in the same form as the problem came. So we'd want to answer as a fraction. Okay? And so that ends up being our answer. We'll talk later about how to check these. All right? So that's one way you can do them. And if you're comfortable with fraction arithmetic, you might just want to do them like you always do. But do notice it requires, little fraction operations in the middle of the problem, even down to reducing and so on. So for folks that are weaker with fractions, there's an alternate way to do these that I'll show on the next slide. And what this method allows us to do, it allows us to clear the fractions from the equation. And what that means is that we'll be able to get rid of all of our fractions, at least until the answer. You just got to understand if a problem comes in fractional form, there's a high chance that the answer is also going to be a fraction. So I started to lay out the steps for this, but I thought we could just look at this equation and you could see how it works first. So here's the equation we just solved doing it with our straight algebra, but let me show you how we can clear the fractions out of this. So the first thing I want to do is anything that's not already written as a fraction, I want to write it as a fraction. So remember, whole numbers can be written as a fraction, just writing it over 1. Okay? And then notice right here I have these three denominators, 6, 1, and 4, right? And what I want to do is I want to find the common denominator of all of them, okay, a common denominator. And if you have trouble finding common denominators, remember one way you can always find a common denominator is to multiply all the denominators together. So 6 times 1 times 4 is equal to 24. Now some of you may notice there's also what's called the common denominator, the lowest common denominator. The lowest common denominator here is actually 12. So if you saw that, maybe try to work through this with me, but use that lowest common denominator. But I'm going to use just the 24. Okay, now what I want to do is I want to take each one of my terms now, leave a little bit of space left to the right of each one of them. Okay, like that. So I'm just rewriting my equation up above. I'm just putting the times next to each one of those. Okay, and I'll explain why in a minute. What we're going to do is we're going to convert all of our fractions here to have this new common denominator. Okay, and so I'm going to want each one of these to be over 24, or if you use that 12, you would use 12. Okay, and so we'll end up with something that looks like this. Okay, so I left a little bit. I didn't need that extra space next to all these fractions, but I'll go ahead and go with it. So the key thing is you just go to each one of your fractions. This one has a denominator of 6, but I want it to have a denominator of 24. So why do I multiply the top and bottom by? 4. So now remember the way we multiply fractions, we multiply straight across. So I have 6 times 4, which is that 24 I'm looking for. But we also do the same in the top. Now, just as it's written, that would come out as x times 4. But remember in the commutative property, I can rewrite that as 4x. Okay, and now I just go to my second one. All right, it's over 1, but right now it's over 1, but I want that denominator to be 24. So what do I multiply this by? I need to multiply it by 24. And so I need to do the same thing on top. Okay, you might need to use your calculator to do this, but 3 times 24 is 72. Okay, like that. All right, and then on our last fraction here, it has a denominator of 4, but I want it to have a denominator of 24. So what do I need to multiply top and bottom by there? By 6. I go and multiply straight across, and that numerator becomes 18. Okay, now you don't necessarily need this on most problems, but I just left too much space, so I'm going to put everything together right here. All right, and here's the nice thing about this technique is if all of your terms, each term in your equation has the same denominator, okay, you can simply cross those denominators out. Okay, now I'm going to point out why you can do that, but you don't need to do that. You can just cross them out. But what we're really doing is we're multiplying both sides of my equation by 24, but the only effect that has is of crossing all those 24s out. Okay, and so once you get your equation that has fractions in it, as long as all the denominators are the same, and again, it's very important that you have an equation to do this. All right, with expressions, we don't just cross denominators out. But if you have an equation and all the denominators are the same, you can simply cross all of them out. And now look what we have. 4x minus 72 is equal to 18. All right, and so now we have an equation with no fractions in it. So now we just finished solving. I would need to add that 72 over. All right, like that. And so I end up with 4x is equal to 90. All right, and then now just isolate x. We divide by 4. We get x is equal to 90 over 4. All right, but that reduces. How does that reduce? It reduces by 2. So I divide top and bottom by 2, and I'd get 45 halves, or that 22 and 1/2 like we saw in the last slide. All right, so this is just another way to solve equations with fractions. You need to figure out try to find which way you're most comfortable with, and hopefully they'll go smoothly. Okay, so that was just an outline of the process. I know it wasn't really clear, but now we can see the steps for how we clear fractions from an equation. So if we want to clear fractions from an equation, make sure at the beginning to write every term as a fraction. And that what the main thing is see if there's any whole numbers, and you need to write those over 1. That's the most common error that people make whenever they clear fractions. They forget to take care of the whole numbers as well. Okay, and so then once you have everything written as a fraction, you find a common denominator from all the denominators, okay? And so remember, one basic way is just to multiply all the denominators. What happened in that last example, since we didn't use the lowest common denominator, notice that we were having to deal with pretty big numbers. And so that's the downside to not having the lowest common denominator. So you might want to spend time trying to find the lowest common denominator first, but that's up to you. All right? And then you convert all terms to have the common denominator. So make sure if the equation had whole numbers in it, make sure to write them over 1 to remind you that those need to get converted too. And then remember what the most important part is that to be able to cross denominators out, all the terms have to have the same denominator. Okay, so once all the terms have the same denominator, you can simply cross them out. Okay, and then they'll be gone then, and then after that, you just solve normally. Okay, and then just remember for this, if a problem came in fractional form, you want to answer it in fractional form. Okay, so let's look at some problems right here, examples. And so, as always, feel free to pause to see if you think if you're feeling comfortable and you think you got it. But let's look at problem 1 now. And so notice that there's a whole number in it. So the first thing I want to do is make sure and write that as a fraction. Okay, now we want to find the common denominator. All right, and so our common denominator, remember the basic way to get it is just to multiply all the denominators together. 7 times 1 times 3 is 21. So that's going to be our common denominator. So what we're trying to do is get it down to the point where all our denominators will be over 21, or all our denominators will be 21. Okay, so we can start with that x over 7. With that, what do you need to multiply the denominator by to get 21? You need to multiply it by 3, but we also need to do it in the top. So then going from here to here, I have x times 3, which using commutativity I can rewrite as 3x. Okay, now we go to our second one. We have minus 2 over 1. I want its denominator to become 21, so I'm going to multiply top and bottom by 21. Okay, and then 2 times 21 in that numerator is going to be 42. All right, and then I go to the right side of my equation with that 1/3. I want to end up getting 21 in my denominator, so that means I'm going to have to multiply top and bottom by 7. So I end up getting 7. Okay, so now we're almost there. The thing is, we got to check, make sure before you do any crossing out that everything is over the common denominator. Everything has the same denominator. We do here, so now we can cross those 21s out. And all we have left is 3x minus 42 is equal to 7. All right, and so now I would just add 42 to both sides, and I get 3x is equal to 49. And then to isolate x, I would divide by 3. I've run out of room once again. If you're doing homework, I would just keep going down. But we got x is equal to 49 over 3. And if you want to convert that to mixed form, that's going to be 1, 6, and 1/3. 16 and 1/3. Okay, like that. Now, while we're here, too, I want to show you how to check these, because we should be checking these. It can get a little bit complicated, but I would use your calculators to check. I know I'm telling you to do the fraction problems by hand, and I do tell you that, but remember, for more complicated checks, feel free to use your calculator, because the thing is here's my original equation, and this is an important thing, too. Probably the most troublesome part on these problems is getting from here to here to the cleared equation. And there's a high chance that you might make a mistake in here. So you definitely don't want to check in this equation. You always check back in the original. Okay, so my original equation is x over 7, but we think x is equal to 49/3. By the way, always check with the improper form. One thing I haven't mentioned enough is 16 and 1/3 is really shorthand for 16 plus 1/3, like that. So if you're going to check with the mixed form, you have to type in 16 plus 1/3 on your calculator, which is kind of a pain. And whereas here, if I use the improper form, I can use just one single number. Okay, and so to do this check, we're filling in 49 thirds to that numerator, but that's also over 7. Okay, and then minus 2, and we're wondering if that is equal to 1/3. Okay, now this is something that I mentioned earlier in the arithmetic review. Remember, if you have operations going on within a fraction, remember this is a divide right here. So anytime you have operations going on in a fraction, or if you just always want to cover your bases, we need parentheses, at least around that numerator. Okay, so we're going to have to type that in with the 49 thirds in parentheses. And so let me show you how I type that in.
Okay, so I have some bad lighting, so I'm having to use my other calculator. You don't need a graphing calculator for this, just the screen is brighter. Okay, and so I'm going to type in, remember I need that 49 thirds in parentheses. So I have 49 thirds. I got to remember what I'm checking here. I got, sorry about that. Yeah, okay, so 49 thirds, and then divided by 7, and then minus 2. So there I've plugged in that 49 thirds to my left side. If you're worried, if you're not sure if you need parentheses around that 7, feel free to use them. And so I could just type, I could put that 7 in parentheses too. It's going to give me the same thing. So remember, your calculator doesn't take equations, so we're going to have to type in the left side, which is this, okay? And that's supposed to equal 1/3. If you don't know the decimal form of 1/3, type it in, all right? And you can see here, we get the same thing on both sides of that equation. So that equation actually, or our answer actually checks.
Okay, so moving on here. Let me get this out of there. Sorry for the. Okay, so now let's do this second equation here. And so again, we have a whole number in that equation. So we have 1/1. One thing I forgot to do after I checked, remember that's a good time to check here to circle your answer there. All right, so we have these three denominators, 5, 1, and 4, and so our common denominator, we can multiply the three together like that. All right, and so that's equal to 20. All right, and so I want to convert each one of my fractions to have a denominator of 20. Like that. Okay, and then you just go one at a time. Now this numerator on this first one might look a little tricky to you at first because it is 2x, all right? And so that's not an equal sign though. But what do I need to multiply top and bottom? The key thing is just pay attention to the numerator, the denominators. I'm trying to get it to 20, so what do I need to multiply this 5 by so that I will get 20? That's 4, okay? And so I do the same thing in the top. All right, now I'm going to write this over here. So you might get confused here, but so what we have in our numerator is 2x times 4, right? But that's 3 multiplications. Remember, there's a multiplication right there. So that's where the associative property comes into play. What the associative and commutative properties say is that I can rewrite those multiplications any way I want. And so that numerator right here actually becomes 8x. All right, and so hopefully that's not too much for you there, but I just didn't have a whole lot of room. Okay, and so then I go to my second one. Right now it's 1/1, but what do I need to multiply it by so that I end up having a denominator of 20, and I need to multiply the denominator by 20, so I'll also do the same in the numerator. And so I have 1 times 20, which is 20. Okay, and then I'm at the 3/4. What do I multiply top and bottom by to get 20? That would be 5/5. Okay, and so multiply straight across, you get 15/20. All right, and so now just take a look at it. All your denominators are 20. So what does that mean we can do? We can we can cross all of those denominators out. And what are we left with? 8x plus 20 is equal to 15. Okay, then we just solve normally. So we have as our variables over on the left, so I want to move my numbers over to the right. Since I'm adding 20 in my equation, I want to move it over with the opposite operation, so I would subtract it. Like that. And so I have 8x is equal to, be careful here with signs, 15 minus 20 is -5. Okay, and then lastly, we need to isolate the x, so we would divide by 8. Like that. And so we'd end up with x is equal to negative 5/8. Okay, so you might want to go through and verify that, plug this in. So if you're going to check this on your calculator, this one's really tricky to check. Okay, this is going to be the check on your calculator, but you're going to type in 2 times negative 5/8. That's your numerator, okay, in parentheses, over 5, and then plus 1. On your calculator, it won't look like that fraction, though. So then you'll say over 5 plus 1, like that. Remember to use the negative key in your check, not the subtraction key. And as long as you use those parentheses, that will give you on your calculator 0.75. Okay? And then we're wondering if that equals 3/4. If you don't know, on your calculator, type 3 divided by 4. It's also going to give you 0.75. So this actually checks. All right, so let's look at one more with fractions. And so here we have, and this one's a little trickier because of those numerators having additions and subtractions. Now, what will help you here, I just thought of this. Remember, whenever we check, we need to make sure and put our numerators in parentheses. So to help you for later, you might want to go ahead and just put those in parentheses, and you'll see why in a minute. Okay, like that. So now, before you get started, remember to find or to write each fraction over 1. Okay. So now, if you wanted to find the common denominator the way we've been finding it, we would just do 5 times 10 times 1, and that's equal to 50. Okay, I'm going to do this one slightly different because I do like you to look for the lowest common denominator. And this is a basic form for whenever the lowest common denominator is smaller than the common denominator. Is notice that 5 divides evenly into 10. Okay, and 1 also divides evenly into 10. So whenever there's a largest number and all the other ones divide evenly into it, that ends up being the lowest common denominator. Okay, like that. So I'm going to use the LCD in this problem. If you paused and tried it with the 50, or if you want to pause and try it, if you think this is the one you would have used, you might want to pause. See if you can go through with that. You'll get the same answer, just the numbers will be a lot bigger because this denominator is so much bigger than that one. Okay, but the key thing is right here. So we're trying to make that first term have a denominator of 10, okay? And so those parentheses will really help you here, okay? And so what do I need to multiply top and bottom by to get 10 in my denominator? And it would be 2, okay? And see, what those parentheses will help you do is, what do I need to actually do right here with this 2? I need to distribute it, okay? And so that's the key thing there. If you distribute that 2 over those two terms, you're going to end up with 2x minus 4, okay? And then plus, now this one's nice here. We have this right here, but remember, what are we looking for? We're trying to get our denominator to be 10. It already is 10, okay? Like that. So whenever a term's already over your common denominator, you can just rewrite it. Then you don't have anything to change. If you like to always think about multiplying top and bottom, what you're multiplying top and bottom by is 1. Okay, like that. And then for that last term, it's over 1. We have 1 over 1. We want our denominator to be 10, so we're going to multiply top and bottom by 10. And so on the right side, we end up getting 10 over 10. Okay, what's key about this? Notice that all our denominators are the same now, and so I can simply cross them out. Okay, and so what do I have left now? 2x minus 4 plus x plus 1 is equal to 10. Okay, now one thing I just thought of too, you might be saying, well, isn't there parentheses right here? And that is true, there technically is, but then what number is in front of those parentheses? So remember, if there's a number not written in front of the parentheses, that would be a 1. But whenever you distribute that 1, you'll just end up with 2x minus 4, and you'd have plus x, or 1x, and then plus 1 times 1 is 1. Okay, like that. So whenever there's 1 in front of parentheses, you can just drop the parentheses. Okay, so now think about how you would progress from here. Remember, we always try to simplify a side if we can. So we have these like terms here. We also have negative 4 and plus 1 being like terms. So 2x plus x is 3x, okay? And then negative 4 plus 1 is negative 3, and that's all equal to 10. All right, and then trying to isolate the variable, we would add 3 to both sides. So we have 3x is equal to 13. And then to isolate x, we would divide by 3. And we get x is equal to 13 thirds. Or if you wanted to convert that, that would be 4 1/3. Like that. And so now the key thing is for checking these, if you're going to check this, you might want to practice this on your calculator. Remember, you need parentheses in those numerators. So you're plugging 13 thirds into this big thing right here. Okay. Really, we just need to plug into the left side since it's just equal to 1. If we plug it in correctly into my left side and hit enter, I should get 1. So if you do your parentheses there, just make sure to use parentheses, at least in those numerators. So you're going to have 13 divided by 3 minus 2. Close those parentheses and then over. And again, you can use parentheses here if you're not sure if you need them. That'll cover your bases. In this case, just using the 5 is fine, whichever way. And then plus parentheses 13 over 3 plus 1, and then divided by 10. Okay, like that. So try that out. Maybe pause a second and just type that in, see if you can get it. But if you go and hit enter there, you should get 1. And remember, that's what we're trying to get it to equal to. Okay, and so that ends up being our answer. So yeah, and I frequently, especially in applications, you end up with equations that have decimals in them. There is a way to clear the decimals out of an equation, but it's a little bit more archaic because we have calculators now that perform operations in decimal form. So this is my advice. You can read how to clear decimals if you want to, but I always just say with decimals, just use basic steps, how we were doing equations before this lecture. And then just use a calculator to do calculations if you need to, if you're not sure how things multiply. So let me show you what I mean with this example right here. So here's an equation that has decimals in it, all right? So, but notice that there's these parentheses right here on the right side. So just as we've always done, if there's parentheses, we want to clear them by distributing. So I'm going to want to distribute that 0.1. So over on my left, I'm not doing anything on my left side. There's no like terms over there, so I'm just going to rewrite it. All right, and then I just distribute that 0.1. 0, anything times x is just that number times x. So I have 0.1x. And then see, this is what I'm talking about. You might not know what 0.1 times 10 is. So just on your calculator, type in 0.1 times 10. All right, and you'll see that you get 1. And so you would just say plus 1. Like that. All right. Now, there's no like terms on either side, so I want to start moving my variables to one side and my numbers to the other side. So I'm going to need to subtract that 0.1x from both sides. Okay, and it's just a matter of how much arithmetic you remember here. But if you don't know what you're going to get here, just remember how this is collecting like terms. So if you need to, now you can't type in variables on your calculator. So you'll just type in 0.3 minus 0.1, what you're going to see is you get 0.2x. Okay, minus 4 is equal to 1. Okay, and then you're going to add 4 to both sides. I was already thinking about what we're going to get. So we have 0.2x is equal to 5. Okay, like that. And then if you divide, so remember what we need to do next. Now we need to isolate x. The problem is x is being multiplied by 0.2, and so the opposite of multiplying by 0.2 is dividing by 0.2. And again, you might not know what 5 divided by 0.2 is, so you just go over and type it in on your calculator, 5 divided by 0.2, and hit enter, and you'll see that you get 25. All right, like that. And so that looks like it's the answer. And then again, with decimal ones, they're kind of nice in a sense that you can use your calculator freely. So if you want to check this, we're plugging this x equal to 25 into both sides of this equation right here as separate calculations. So the first thing you're going to type in is this left side. So you'll type in 0.3 times 25 minus 4. Okay, and I'm doing that right now on mine. 0.3 times 25 and then minus 4, and I hit enter, and it gives me 3.5. Okay, and we're wondering if that equals, plugging in on my left side or on my right side, I have 0.1 parenthesis x. We think x is 25, and then plus 10. Hopefully you see what I'm doing there. I just plugged x equals 25 into this right side right here. So I end up with this. And just type it in exactly like it is on your calculator. So 0.1 parenthesis 25 plus 10, close the parenthesis, and then hit enter. Like that. Right here we were wondering if they're equal. After you hit enter though, it gives you 3.5 as well. So those do check. All right. So with decimals, you can look into how to clear them. What ends up happening whenever you clear decimals, is especially the whole numbers, they become very big. So you got these really big numbers to deal with. So me personally, I just like to work with them, and then if anytime I'm not sure what some calculation is, I just plug it in on my calculator to get it. Okay. So I hope that helps. You really want to get comfortable with solving equations that have fractions or decimals in them, because a lot of very practical problems involve that, which is what the next few lectures are going to be dealing with. Now that we've got down the basics of solving equations, we want to see why that might be useful. So all the best.